Okay, so in this section, we're going to look at piecewise functions. Right, so we're going to start by one of our toolkit functions that we discussed earlier, and that one is the absolute value. And we're going to write this as a piecewise function, right? So first of all, what do we know about our piecewise, or excuse me, about our absolute value function? If we look at the graph of this function here, it looks something like this. And again, x and y, or just a couple of points here. This is 1, this is 2. Right, this point is 1, 1. This point is 2, 2. And then on this side, let's say negative 1, negative 2 along our x value. It's negative 1, 1, and negative 2, 2. Okay. So again, the absolute value gives us the value, right? Doesn't care about the sign as our output, right? Whatever that value may be. Okay, now we can write this as something that is known as a piecewise function. Piecewise meaning there are different pieces to our function here. So if we take this here, there's an obvious, we can see a different like breaking point essentially of our graph here. I can rewrite the absolute value function in two parts, right? Without essentially dropping these absolute value signs. The first part, I'm going to look at values that are 0 or positive. Right? In that case, the value of x is simply x. Right? And this is if x is greater than or equal to 0. Right? Now, when we look at the negative values, here, when I plug in negative 1, I essentially get the opposite. Right? Negative 2, I get 2. So for these values that are negative, I'll just take the opposite, another the negative value of x, right? If x is less than 0. All right. Now just take a moment to convince yourselves that this expression does yield a positive value. Right? When students see negative, they always think, oh, this is negative. This actually is not negative, right? Because remember, look at the components of these piecewise functions, right? There's two pieces here, right? Now, which one I use depends on what the input is, right? If the input is bigger than 0, this first part takes over. Excuse me, bigger than or equal to 0. If the input is less than 0, then the second part takes over, right? Now, it's still a function in the sense that each input corresponds to exactly one output, right? Now, which one of these I use really depends on what my input is, right? So what I mean by that is, well, if I had, and again, right, no more absolute value, simply our piecewise function has two pieces here. All right, let's say I wanted to find f of 3. All right, how do I evaluate that from this piecewise function, right? Which one do I choose? Well, is 3 bigger than or equal to 0 or less than 0? It is bigger than or equal to 0. In that case, you simply leave it alone and you get 3. All right, now how do I evaluate f of negative 5? All right, and again, look at your restrictions here, right? Which condition does this fall into? Is it greater than or equal to 0 or less than 0? This is negative, so it is less than equal to less than 0. So what do we do here? We use this part of our piecewise function. So it's the opposite of whatever x is. In this case, we get 5. Right, so see how it works exactly like my absolute value function. Except this time it is a piecewise function. All right, so that is what we refer to as a piecewise function. Notice there's not going to be any overlap in these intervals here, or else it would not be a function. In that case, we won't be able to determine which interval does it fall in. Right, it can't fall into 2. Right, they cannot overlap. Okay, so now let's take a look at an example of how we would graph a function like this. So here, for this example, graph x squared if x is less than or equal to 1, 3 if x is less than or equal to 2 but bigger than 1, and x, the identity, if x is bigger than 2. All right. Now, individually, we know what these three functions look like, right? X squared is my quadratic, right? These are a part of our toolkit functions. 3 is a constant function. And then x is my identity function, right? And I know what the shape of each one of those looks like, right? But here we have domain restriction, right? So here, let's set up a graph here. Okay. And let's take a look at graphing the first part of my piecewise function, right? So I know what a quadratic looks like. That's 1, 2, 3, 4, and -1, -2, -3. Okay. Okay, so in this case here, when x is less than or equal to 1, we have our quadratic. So in other words, for all values that are to the left of 1, right, the quadratic is the function that's going to take place. All right, notice here it includes 1, so when x is 1, 1 squared is 1, so the value is in fact part of the graph, right? And just graphing the quadratic, it looks something like this, going off in this direction. All right, so that's our first part of our piecewise function. All right, now between 1 and 2, the function is constant at a value of 3. Between the interval not inclusive of 1, so in fact here we have an open circle to indicate that it is not including the value of 1, but it includes every other value greater than 1 up to, and in this case, including 2. Okay. All right. And now here, for the last part, we have our identity when x is greater than 2, right? So here the identity is if x is 2, then y is 2. If x is 3, then y is 3. So I have 2. It looks something like this. All right, so that would be for all values greater than 2. It's this identity line. And notice this is our piecewise function. Still a function, right? Passes our vertical line test. So we graph them at each of those individual intervals, right? Okay, notice it would be incorrect to draw the whole quadratic, the whole constant, and then this whole identity. That is not the graph, right? The graph, the quadratic only exists in this interval. The constant only exists within this interval. Okay, so let's say, for instance, if we were evaluating, right, let's say you wanted to know what would f of -3 be, right? Well, which interval does this lie in, right? This is -3 is negative, so it is in the less than or equal to 1. So that would be the quadratic. Now, where would, let's say, something like 1.5, right? 1.5 is somewhere between 1 and 2, midway here. And in that case, that is our constant function. So in that interval, it's always 3. Notice only one value, right? This is still a function, right? Each input gives me one value. Right? And something like, let's say, f of 5. Right? 5 is in the interval x greater than 2. So just plug in whatever that value is, the identity. So it's just 5. Okay, and that's how you graph, and a couple more examples of evaluating piecewise functions.